Students, you all are familiar with the trigonometric values of angles in the first quadrant. Today I will tell you how to evaluate the value of the angles if it lies in the second quadrant or third quadrant or fourth quadrant using the allied angles. So first let us take this angle sine 120 degree. Trigonometric function sine 120 degree, its value. So first let us draw the quadrants. First, second, third quadrant, fourth quadrant. Now, angle of 120 degree lies in the second quadrant. It is greater than 90 degree, less than 180 degree. So, it lies in the second quadrant. We want to evaluate the value of the functions sine of 120 degree. You all are familiar with the value of trigonometric functions at allied angles. In the last part I told you about allied angles. So sine 120 degree, we can write this is equal to sine of 180 degree minus 60 degree. And in the allied angles I told you the formula sine pi minus theta or sine 180 minus theta is equal to sine theta, because the angle lies in the second quadrant and using the ASTC rule we will find the sine. In case of 180 degree there is no change in the function, sine remains sine. In the second quadrant sine and cosec are positive, so this is equal to plus sine 60 degree is equal to under root 3 upon 2. Now the second value cos 150 degree. Again the 150 degree angle is in the second quadrant, and in the second quadrant sine and cosec are positive, so I can write this cos 150 is equal to 180 degree minus 30 degree. And you know in the second quadrant only sine is positive, so cos is negative here. Cos 180 minus theta, you know this is equal to minus cos theta, and minus cos 30 means the value will be equal to minus root 3 upon 2. Third, tan 135 degree. Again 135 degree angle is greater than 90 degree, less than 180 degree. It lies in the second quadrant, and in the second quadrant tan trigonometric function tan is negative. So tan 135, first I can write this as 180 degree minus 45 degree, and in the case of 180 degree there is no change in the function, so I can write this is equal to minus tan 45 degree, and minus tan 45 is equal to minus 1. So the value of tan 135 degree is equal to minus 1. You can also evaluate this function using 90 plus angle. So sine 120, you can write sine 120 degree is equal to sine of 90 degree plus 30 degree. 90 plus theta means you are in the second quadrant. Second quadrant sine is positive, so this is equal to cos 30 degree, and cos 30 is equal to root 3 upon 2. So sine 120 can be evaluated using the concept 180 minus some angle or 90 plus some angle. Similarly, cos 150 degree is equal to cos of 90 degree plus 60 degree. And you know, in the second quadrant, cos is negative. Value of cos function is negative. And in case of 90 degree, cos changes to sine. So this is equal to minus sine 60 degree is equal to minus root 3 upon 2. So the same value you are getting ultimately. So this is up to you whether you use 180 minus theta concept or 90 degree plus theta concept. So these were the values of the trigonometric functions which lie in the second quadrant. So these were the angles in the second quadrant. Now let us consider some angles in the third quadrant. For example, if I consider sine 240 degree, so third quadrant, sine 240 degree. Sine 240 degree angle is greater than 180, that is it lies in the third quadrant. And in the third quadrant, tan and cot are positive. Rest of the trigonometric functions are negative. So sine of 240, first I will write it in the form 180 plus 60. 180 plus 60, sine 180 plus theta, you know, in the third quadrant it will be negative. So minus sine 60 is equal to minus under root 3 upon 2. Then the next angle in the third quadrant, cos of 210. Cos 210. 210 degree angle lies in the third quadrant because it is greater than 180, less than 270. So cos 210 is equal to cos 180 plus 30 degrees. In case of 180 degree, there is no change in the function. So cos will remain cos, and in the third quadrant cos is negative. So this is equal to minus cos 30 degree. And minus cos 30 means this value will be equal to minus root 3 upon 2. Next is tan 225. 225 degree angle is again greater than 180 degree, less than 270 degree. It lies in the, this angle lies in the third quadrant. So tan of 180 degree plus 45 degree. And in the third quadrant, tan is positive. From this side we observe the angle. Tan is positive, tan is here, tan is positive. So this is equal to plus tan 45 degree, which is equal to 1. These were the values of the angles which lie in the second and third quadrant. How to evaluate the value of the trigonometric function for which the angle lies in the fourth quadrant. So first let us start with cos 315. Cos 315 degree, this angle is greater than 270 degree, 90, 180, 270 and less than 360. It lies in the fourth quadrant. I can write cos 315 degree is equal to cos 360 degree minus 45 degree. And this is equal to, in the fourth quadrant, cos and sec are positive. We have cos here, so it will be positive. So this is equal to cos of 45 degree. One more point, that in 180 degree plus minus or 360 plus minus, there is no change in the function. So cos for 45 degree is equal to 1 upon under root 2. Next angle, tan 330 degree. 330 degree angle lies in the fourth quadrant. So I can write tan 330 degree is equal to tan of 360 minus 30 degree. Because from 360 if we subtract 30 degree, then we get 330 degree. Now, in the fourth quadrant, cos and sec are positive, rest of the values are negative. So this is equal to minus tan 30 degree. And this is equal to minus 1 upon under root 3. Then one more trigonometric function, cosec 300 degree. Again, 300 degree angle is more than 270, less than 360. It lies in the fourth quadrant. So I can write this is equal to cosec of 360 degree minus 60 degree. And there will be no change in the function. So this is equal to minus cosec 60 degree. Cosec 60 is reciprocal of the sine. Value of sine 60 is under root 3 upon 2. So the value will be minus 2 upon here, minus 2 upon root 3. So with this concept, you can find the value of the angles which lies in the second, third and fourth quadrant. If you want to evaluate the bigger angles, then we have a concept for it. Suppose for an angle, the terminal line is along OA. Now if I rotate this line by 2 pi radians, then again it will be along OA. If I rotate it by 4 pi radians, means 2 rotations, then it will be along OA. So for the angles of the form theta plus 2n pi, it will represent the same terminal line, theta plus 2n pi radians. So if I find sine theta plus 2n pi, this will be equal to the value sine theta. This is true for all the trigonometric functions. Similarly, tan of theta plus 2n pi, this is equal to tan theta. Or cos of 2n pi plus theta, this is again equal to cos theta. Means it is true for all the angles. So if we want to evaluate an angle which is more than 2 pi radians, then we will write it in such a way that it is some multiple of 2 pi and plus some angle. Then it will be equal to trigonometric function of that angle. If we write the angle in the form 2n pi minus theta, in that case the value will be equal to sine of minus theta, that is minus sine theta. So for multiple of 2 pi minus some angle, sine, all the trigonometric ratios except cos and sec are negative. Cos 2n pi minus theta is equal to cos of minus theta. Using the same concept here, this will be equal to cos theta. Tan of 2n pi minus theta will be equal to tan of minus theta is equal to minus tan theta. So if we want to evaluate an angle greater than 2 pi radians, we can write it in this form, some multiple of 2 pi plus some angle, and then it can be easily evaluated. So I will illustrate this method by taking some examples. Now let us find the value of sin pi up pi 5 pi upon 3. Now I will bring this angle in the form of 2n pi plus minus theta. So this is equal to sine. If I want to bring 2 pi here, so I will write some multiple of 3, which gives a multiple of 2, that is 6 pi minus pi. 6 pi minus pi is 5 pi upon 3. Now this is equal to sine 6 pi upon 3 is 2 pi minus pi upon 3. It has come in the form 2n pi plus minus theta. 2n pi minus theta. So this will be equal to minus sine pi upon 3 and minus sine 60. 60 is minus root 3 upon 2. So what we need to do in these questions, you need to bring some multiple of 2 pi. Then we can use the formula sin n into 2 pi plus theta is equal to sin theta, or sin n into 2 pi minus theta is equal to minus sin theta, or whatever the trigonometric function we have. Next, sin 17 pi. So again I will write this in the multiple of 2 pi. 17 pi multiple of 2 pi, 2 8 is 16. I can write this is equal to 8 into 2 pi plus pi. Now it has taken the form 2n pi multiple of 2 pi. In that case, n is a positive or negative integer. So here it is positive integer. So 8 into 2 pi plus pi. This is equal to sin pi, and sin pi can be written as sin pi plus 0 or sin pi minus 0. So this is equal to sin pi plus 0 is equal to minus sin 0 is equal to 0. If you write this as sin pi minus 0, then plus sin 0 means 0. It is 0. Now tan 11 pi upon 6. Here also I want to bring some multiple of 2 pi, maybe 2 pi here also. So tan, and here the multiple of 2 pi, you can write this 11 pi is equal to 12 pi minus pi upon 6. Now if I separately divide, then 6 to the 2 pi minus pi upon 6. I am in the now 2 pi minus some angle means you are in the fourth quadrant, and in the fourth quadrant tan is negative. So this is equal to minus tan pi upon 6. Pi upon 6 means 30 degree. So the value is equal to minus 1 upon root 3. Some more values now. Evaluate cos of minus 25 pi upon 4. So if you have a negative angle, first tackle the negative sign. Cos of minus theta is cos theta, so this is equal to cos of 25 pi upon 4. Now this fraction we need to remove in such a way that we get it in the form of 2n pi plus some angle or 2n pi minus some angle. Means even multiple of even multiple. So 25 pi I can write, this is equal to 24 pi plus pi upon 4, because 4, if I divide, then 4 24 6 times, 6 pi. 6 pi is a multiple of 2 pi. So cos of, if I divide 24 pi divided by 4, 6 pi plus pi upon 4, which is in the form of cos 2n pi, means n into 2 pi. So this we can write, this is equal to cos 3 into 2 pi plus, means some multiple of 2 pi plus pi upon 4, which is equal to cos pi upon 4, and the answer is 1 upon cos 45 is 1 upon root 2. Now 17 pi upon 6. 17 pi, you can write 6, 18, 3 times, then 4 times 4 pi. 4 pi means even multiple of 2 pi. So I can write, this is 24 pi minus 7 pi upon 6, which is equal to sine 24 pi divided by 6, 4 pi minus 7 pi upon 6. Multiple of 2 pi here, 4 pi is multiple of 2 pi, n into 2 pi. So this is equal to sine of minus 7 pi upon 6. That is minus sine 7 pi upon 6, which further can be solved. 7 pi upon 6 means minus sine 6 pi plus pi upon 6, which is equal to minus sine 6 pi divided by 6 is pi plus pi upon 6. Now pi plus some angle, you are in the third quadrant. In the third quadrant, sine is negative, so this is equal to plus sine pi upon 6. So already negative sign is there, minus minus becomes, so this is equal to sine 30. Sine 30 is 1 upon 2. So what you need to do in these questions, you need to bring some multiple of 2 pi. Then using the formula n, 2n pi plus theta is equal to the same sine of the same angle. Sine 2n pi plus theta is equal to sine theta. So here 17 pi I can write even multiple. Even multiple is 24. You can also solve it using 12 pi. Then you will have to write 12 pi plus 5 pi upon 6. Now this value sine 41 pi upon 6. How to evaluate it? So if I take this as 36 pi plus, this is equal to sine 36 pi plus 5 pi upon 6. Then this value is equal to sine 36 pi divided by 6 is 6 pi plus 5 pi upon 6. Sine n into 2 pi means you can add, this is 6 pi is 3 into 2 pi, 3 rotations of 2 pi radians. means this will be equal to sine 5 pi upon 6. 5 pi upon 6 can be written as sine of 6 pi minus pi upon 6, which is equal to sine of 6 pi upon pi minus pi upon 6. Pi minus or sine 180 minus theta means you are in the second quadrant, and in the second quadrant sine is positive, so this is sine pi upon 6, and sine 30 is equal to sine pi upon 6 means sine 30. Sine 30 is equal to 1 upon 2. If the angle is bigger and it is in the form of degrees, in that case you can use the concept sine n into 360 degree. If plus theta is there, plus theta is equal to sine theta, means take the rotations of 360 degree, means divide that angle by 360 degree. So in that way you can tackle the angles which are in degrees. Similarly, if you write that angle as n into 360 degree minus theta, then it will be equal to sine of minus theta, that is minus sine theta. But in the case of cos, if you have cos n into 360 minus theta, that value will be equal to cos of minus theta, and cos of minus theta is equal to cos theta. So in this way you can evaluate the angles which are bigger than 360 degrees, or so with these questions I conclude today's session. Like and subscribe my channel for new videos, and wait for some more important topics to come.